Good morning, my dear students. How are you doing? Our lesson today is talking about the integration by parts. Integration by parts. The main idea here is to see if the function given included the product of two functions like u and dv. So your rule will be uv minus the integral of v du, such that u is the first and v is the second, and dv is the second function. And here in this question we're gonna use derivatives and integration in the same time. We will find the derivative of u to obtain du, and we will use the derivative of dv to find the value of v. Okay, but here what are the guidelines to find u and dv? It will be easy to you to use this word, which is late, L-I-A-T-E. Yes, which is L stands for ln and log, ln or log, logarithms. I stands for inverses, like tan inverse, sine inverse, and so on. A stands for algebraic functions, and T stands for trigonometric functions like tan, cosine, sine, and so on. E stands for exponential function like e to the power of something, and 2 to the power of x, and all exponential function. You know it. So the guidelines for choosing u is following the word late. Okay. Next, we will solve one example here. The first example in my lesson is find the integral of x cubed ln x dx. It's so simple and easy, so all of you pay attention, please. First of all, we will let the first here is u. No, wait, mister, you said for us to follow the late word. So late, and we said L stands for what? L-I-A-T-E. So to choose your u, which is, who comes first here? The late, the L. L here stands for logarithm, and we have ln, and ln is one of the family of logarithmic functions. So u is ln x, and sure, the dv is x cubed. Okay, then we would like to find here the derivative of the first, which is u, and the integral of the second choice, which is dv. What's the derivative of u? It's du to the respect of x. And what's the derivative of ln x? Which is 1 over x dx. Here you should find the value of v. We should find the v. To find v here, you should take the integral for both sides. And what's the integral of dv? Is v. The integral of x to the power of 3, it's so easy. We're gonna add 1 to the exponent and divide by the new exponent. We're gonna add 1 to the exponent and divide by the new exponent. Right. Okay. Then you substitute in the formula. We said that to use the by parts, integration by parts, we should substitute in uv minus the integral of v du. Then here, what's the value of u now? U is ln x. Then v, which is x to the power of 4, over 4, which is 1/4 x to the power of 4 ln x. So the v is 1 over 4 x to the minus the integral of v. The v is 1 over 4 x to the power of 4 and du again is here 1 over x dx. Okay guys, here then simplify. The first part here stay the same, 1 over 4 x to the power of 4 ln x minus 1 over 4 is a constant, so we will let it outside here, and then the integral of x to the power of 4 over x. We can cross out here the exponent and we still have only x to the power of 3 dx, which is so simple and easy now. So simple and easy now. Your answer is 1 over 4 x to the power of x to the power of 4 ln x minus 1 over 4 is a constant, and then the integral again of x to the power of 3 is x to the power of, yes, correct, 4. We add 1 to the exponent and then divide by the new exponent, which is 4, and don't forget the constant of the integration. And here we integrated by using what parts? 1 over 4x to the power of 4 ln x minus 1 over 4 times x to the power of 4 over 4 plus c, and here we can multiply, will be 1 over 4 times 4 is 16. You can leave your answer in this form, no problem. Okay guys, okay, one more example. Example 2. Example 2. Okay guys, example 2. Okay, example 2. One more example, how to use by parts, integration by parts to answer your question. Find the integral of sine x and then ln cosine x as an angle dx. First of all, we should decide what is u and what is v. Let a. To choose u, you should follow this word, which is let a. Let a means the logarithms comes first, so this one will be u and the other part of the question will be dv. At the right here, we will let u is equal to ln cosine x and directly find the derivative. The derivative of ln is ln something. Ln x is 1 over x. The derivative of ln x squared is 1 over x squared, then times the derivative of the inner function inside derivative. So here the derivative of ln cosine x is 1 over cosine x, no problem, then times your answer by what? Times your answer by the derivative of the inner function, which is cosine. The derivative of cosine is negative sine x. Take care guys, chain rule. The second part is dv, right? The dv will be sine x, and here the integral v is equal to the integral of sine is so easy, is negative cosine x, right? Is negative cosine x. Okay, then would like to complete our answer. What is the next step? The next step is to substitute in the formula uv minus the integral of v du. So don't forget this formula. We're gonna use it to integrate by parts. The value of u, what's the value of u? Here, u is ln cosine x. Ln cosine x times the v, which is negative cosine x. And take care, guys, here. Most of the students fall in this mistake. They multiply cosine by negative cosine x, and they say that the answer will be ln cosine squared x. No, no, no. Here is an angle, and here another function, which is negative cosine x. Ln cosine x is a complete function, and the negative cosine x is another function multiplied by the total function ln cosine x. Let's continue here. The integral of v, what is v? Which is negative cosine x du, this all here, the du, which is negative sine x, this all over cosine x, right? Yes. Dx, we forgot here the dx. Okay. Then the answer will be negative cosine x ln cosine x. We have negative, 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 which is negative, is still negative. And this all integral of, cross out cosine with cosine, right? And the answer will be the integral of sine x dx. Nice. The final step to write this one the same, and this term the same. Ln cosine x. Yes, this all will stay the same here. Minus, what's the integral of sine? It's a negative sine, so negative by negative is positive. Integral of sine is negative cosine, right? Okay, so we have negative multiplied by negative, gonna be positive, and the integral of sine is negative cosine, so negative, negative, positive, cosine plus c. So this is our final answer here, right? Okay, one more example for by parts. Yes. Example number 3. Example number 3. Okay, the second example here. What is the integral of x cubed root 4 minus x squared? And this case is very important to you. We said to choose you should follow the latte word, right? So latte means logarithms, inverse functions, algebraic functions, and trigonometric functions, and exponential. So we will find that we have x to the power of 3 is algebraic function, and root radical 4 minus x squared is also algebraic function. So which one will be? Both of them are algebraic functions. So in this case, take care, this question is tricky. When both of them algebraic expressions, so we will let dv be the most complicated portion of the integrated that can be easily integrated. Again, let dv be the most complicated portion of the integrand that can be easily integrated. So what is the part here that will be most or more easily to be integrated? I think here radical 4 minus x squared will be the most easily for integration. Yes, right? So here dv will be radical 4 minus x squared. But if you think for a while, you will find that to find the integral of radical 4, to find the integral only of radical 4 minus x squared dx, you should use here the substitution way you have still in the beginning of this term. We will let the inner function u, right? We will let the inner function z, any variable, right? 4 minus x squared. And then you will find the derivative here, which is dz, and you will find the derivative here, which is negative 2x dx, and then isolate the dx alone in one side. So dx is equal dz over a negative 2x, right? Yeah, correct. But when you here substitute again the integral of the integral of not u, z, we let it z. The integral of z, sorry, radical z, because we let only the inner function 4 minus x squared z, so the root z times the dx which is dz over negative 2x. Oh, we still have here x, right? So in this case we will not be able to integrate by this way, or let only the dv radical 4 minus x squared. So what is the idea here? What is the trick here in this question? The trick here in this question is to take 1x from the x cubed. Is take 1x only from the x cubed, because as you saw now, we need 1x here to be cancelled with the x in the denominator with 2x, right? Yeah. So my dv here will be, here pay attention, my dv so the dv here is equal to x radical 4 minus x squared, and the integral for both sides will be, yes, we will take 4 minus x squared as z. So it's x, then root z times what? Times dx. We cannot do it quickly here, so let's do one step by step. First of all, to integrate this, I should let z is equal to 4 minus x squared, right? Okay, then the dz is equal to negative 2x dx, as we have in the substitution way. Then dx is equal to dz over negative 2x, right? Very good. And then integrate here the two parts. The integral of dv is v, and the integral of x root, we let all the inner function z, times what is the dx here? The dx is dz over negative 2x, and that's why we repeat again this this function. We rewrite again this function. I took 1x from the x cubed, okay, and still here x squared times x, and this x with the root becomes dv. The integral after that by substitution way, the v equal this all for v, we didn't start the part till now, which is the integral of x root z times dz over negative 2x. I think that we can cross out x with x, and easily now we can find the integral of root z, which is 1 over the integral of what? Of root z, which is z to the power of half, and then the integral of z to the power of half, and this all over negative 2 dz. The negative half is a constant, and we have z to the power of half plus 1, which is 3 over 2, and this all over 3 over 2, which is 2 over 3. You know how to do it now, which is negative 2 over 6 z to the power of 3 over 2. Okay guys, which is at the end negative 1/3 z to the power of 3 over 2, and this all is the value of v. In the next slide I will take here u. What is u? Is x squared. Take care that u is x squared, because we already took 1x from the x cubed. We still have only here u is x squared, and the derivative here easily is 2x. So easy. Now we will start my parts, which is uv minus the integral of v du. What's the value of u? The value of u is x squared, and the value of v from the previous page, v is negative 1/3 z to the power of 3 over 2. Yes, negative 1/3 times z, which is, yes, 4 minus x squared. Excellent. And this all over, this all to the power of 3 over 2. This all to the power of 3 over 2 minus the integral again of v, which is, we can write it easily as, leave it as a rational exponent, which is 4 minus x to the power of 2, and this all to the power of 3 over 2 du, which is 2x. Oh my god, dx, right? 2x dx. Listen, here in this question, this all will stay the same, but we have another problem here. What's the problem in this question? That we should use substitution way again. We should use substitution way again. So in this part only, I will let you, not you, let's let here another variable, which is z again by substitution way, which is 4 minus x squared, and then dz is equal to, then the derivative here is negative 2x dx, right? And dx is equal to dz over negative 2x. To solve this part of the question, we will follow the substitution way. Pay attention, guys. I know that this question is not easy at all. The final step here, we will do it in the next part, which is the integral of 4 minus x squared, and this all over what, this all to the power of 3 over 2 times the next page, times 2x. Let's write it again. The integral of 4 minus x squared, and this all to the power of 3 over 2 2x dx. The previous, yeah, correct. And we said here that this is the dx and this is the z. So it's here z to the power of 3 over 2 times the 2x, same, but dx is dz over negative 2x. Now it's so easy to cross out 2x with the 2x, and this negative will be multiplied by this one. Yes. So your final answer is negative 1 over 3 x squared. The final answer is negative 1 over 3 x squared times 4 minus x squared, and this all to the power of 3 over 2. I took this part the same, and this minus will be plus since we have here minus. Okay, it will be plus the z here. The integral of this z will be z to the power of 5 over 2, and this all over 5 over 2, or 2 over 5. So we have 2 over 5, and the z is 4 minus x squared, and this all over to the power of 5 over 2. Okay, guys, and this all plus c. This is my final final step. Thank you guys for watching this video. I hope you understand everything, and good luck, guys. Goodbye. Sorry guys, here I forgot only the negative 1/3 here, the negative 1/3, so it doesn't matter, but will it change the final answer? this all is correct except only this part. This part will be negative 1/3, so this wall will be negative 2/15. Sorry for this mistake, but the answer is all correct except this part, because don't forget that this v is including negative 1/3. So the final answer only is 2/15, negative 2/15, since the v is negative 1/3. Okay guys, thank you, goodbye.